I would be giving you a brief on what is Microsoft.NET. And it is like, if you are interested in coding and programming and want to pursue your career in the same, so you can, it is very beneficial for you in today's date. So let's start. Okay, so starting with the world of software, I believe that whenever we start with anything, like we want to learn a new skill or learn anything, a new technology, we should start with the history of the technology or with the history of the evolution of the same. So if we talk about .NET, it is a kind of software. So we'll start with the history of software, or the world of software, introduction to the software. So like in today's world, we are moving towards the digitization and the automation. So everything, you know, is a form of software in today's world, like whether it's the education sector, the healthcare sector, the agriculture sector, any sector, like helping elderly, it is also helping the elderly, helping differently abled. We have different kind of software for helping everyone in the world. So the automation and digitization is like what we call an automation and digitization. Like we create softwares, we implement into the hardware. So that is called the automation and digitization. So it can be a website, a game, or any software like Word, PowerPoint. Everything is a software in today's world. So we also have softwares in our day-to-day lives, like we have washing machines, we have smartwatches, we have smartphones, everything, they all contain the software, like we have CCTV cameras and things like that. So everything is digitized. So all are in a form of softwares. Moving forward, so if we talk about the history of software, the first working software was in 1948, which was named the Manchester Baby because it was made in Manchester. So it was a small scale experimental machine, which was like tested for the, like when the RAM was made for the first time, random access memory, for that it was a testing model. So after we got this testing model, the Manchester Baby, we had developed several kind of random access memories and different kind of softwares. And then finally, in after a couple of years, we got our first working, what you call PCs and computers after this test was successful. So it, like, the history of software goes back to 70 long years. So such is the significance of softwares in our lives nowadays. So the era of personal computers began in 1970s and 80s. Before that, it was only used for defense purposes and the not for common purposes, just the specific purposes like healthcare and defense and things like that. But after we have developed the software for personal use in 1970s and 80s, it was available to the common people. So the programs started to begin. Earlier, it was just electrical and mechanical, and then we started softwares, like writing softwares in assembly languages in 1979. The first assembly language program was introduced and written before 1979, tested and all the things done, but it was introduced to the world, to the common man in 1979. So after that, we got introduced with an operating system called Linux, which was an open source. Open source, what do you mean by open source? Open source software is someone where we have the coding or the programming of the software available for the common people to modify it. Like you can take the source code, suppose we have Linux. So Linux, you can take the source code, you can modify and build a new version of it for yourself. So why Linux is a open source software? Because earlier it did not get licenses for, you know, for being licensed, or it got patented, but it got some legal issues, so it did not get licensed. So the founders of Linux, they provided it for free. And so the reason, like because it was free and it was an open source, so it got developed so much that till now it is in use and widely used software in the world. It is one of the widely used operating systems. So moving forward, in 1998, we had source codes written in C and C++. Then we had Java by Sun Microsystems, now Oracle, which was introduced in 1995. So with further advancements, we had PDAs, like we had personal phones and things like that. So since last 20 years we are working on mobile softwares. Like you can carry it anywhere you want and then you can use it. So history of the softwares goes back. Yeah, let's go to the current trends. What are we having today? So with the introduction of C language, we got an idea of high level languages. Like we had assembly languages before, but it was not a high level language. Assembly language is kind of machine language. We have the language of zeros and one, which only the computers understand. Then we had assembly languages, which were kind of the instructions. Like we had instructions, and then those instructions were converted into the low level language as in machine language, and then the computers understood it. Then we had high level languages. High level languages are the languages which are completely understandable by common man or common humans. They contain the English like words like for, then loops, and then while, do while kind of things. Then we had object-oriented programming paradigm. What is object-oriented? Like earlier in C, we had structured languages. In structured, what we had is like we had a paradigm like we top to bottom technology. Like we had a high-level blueprint first. Then we used to construct the inner things. Like if we take an example of a house, when we build a house, what we do is we create a blueprint, or we create the structure of the house first. Then we insert the windows, the doors, and everything inside. So with object-oriented, that was structural. Then with object-oriented, we came as a bottom to top approach. Like we build windows and doors first, and then we planted them into the house. So it was like that. Everything is in the form of object. Like we had every object in the world, you can specify that as an entity in an object-oriented programming language. So that is more relatable. So going back to 1960s, we had our first language called Simula by object-oriented programming paradigm. And since then, we are following the object-oriented programming, and it is in use till date, where we are, changing every day in the rapidly changing universe. It is still surviving because it is very relatable. Like it is very easy to relate with the OOPS programming paradigm. And the second thing is the reusability of the code, because it contains inheritance. So we can reuse the code that we have earlier written, and we can modify it and use in our further classes. So then came .NET, which is our subject for today. So Microsoft is the parent of .NET. Microsoft designed .NET in 2002, and till now it is widely in use. You can call the Java and Microsoft .NET, both are competitors, because in Java also performs the similar functions like developing high-level softwares in today's world, and .NET also does the same work. So if we talk about the languages, .NET supports as many as 60 languages, 60 programming languages, and evolving. The specific language which was developed for the support of .NET was C#. C# is specifically used when we develop .NET programs. So C# and Java, both are rivals, and both do the similar kind of things. So apart from that, we have a tool which is also developed by Microsoft.NET and is written in C# only. So the tool is named Visual Studio. It is an IDE which provides an integrated environment where you can develop the program, where you can just write the code, develop the program, compile it, build it, test it, and then you can deploy it. So all the functions, since all the SDLC functions you can have in this Visual Studio tool itself. So it's a all-in-one tool, you can say. If you have Visual Studio, you don't need anything else for developing a program in .NET. Yeah, so moving towards, nowadays there is an issue like we are moving towards more and more storage, more and more data. Every day we have tons of data that comes, tons of traffic that comes and goes into the internet. And then data is something which is needed to be stored physically somewhere. So more data means more storage. So storage is something which is very, very costly. But nowadays, people are moving towards cloud storage, cloud computing, where you can rent a storage developed by other companies. Like we have data centers developed by big companies like Microsoft, Amazon, Google, and then we can just rent it out. So going forward, when we go towards cloud storage, it is like pay-per-use facility, which we call SaaS, which is software as a service. So we have different kind of things under software as a service. Like we have hosted applications, development tools, DBs, servers, network firewalls, data centers. All these come under software as a service. Like you can use the things built by other companies, and then you can rent it out for however use you want it. Like you want to use it for 1 hour, you pay for 1 hour and use it. You don't have to build a thing of your own, which is if you build a data center, it will take huge cost. But if you will rent a data center, it will cost you a lot less than what originally it would take. So we had like platform as a service, which contain development tools, like they are the subsidiaries of software as a service. Then we have infrastructure as a service, which contain these physical storage kind of infrastructures which you can rent. So these are the advancements that we are making as of today. So artificial intelligence and machine learning, everyone knows that we are moving towards artificial intelligence and machine learning, which is the future of tomorrow. Like we'll move into the world of AI altogether. So going forward, what is the state of art in the world of .NET? So we have some highly significant software which are made in .NET itself. So some of the examples are which are written in the slide: Unity 3D, RavenDB, KeePass, and so on. So let me tell you a bit about all of those. Like Unity 3D, it is a kind of gaming software or a gaming platform, game engine, where you can create cross-platform games. So it was earlier made for making or developing Mac OS games in 2005, but as of 2018, it contains like the engine is developed for making cross-platform games, and also it supports more than 25 platforms as of now. So the Unity 3D can be used for creating 2D, 3D games, like virtual reality games, augmented reality games, then also the simulation of different kinds. Like we have aircraft simulation, train simulation, if you want to learn how to fly a plane, how to ride a train, how to ride a car, how to ride a bike. We have all the simulations which can be made by using Unity 3D framework. Yes, complete concept of .NET can be done in Visual Studio, starting from the development till the testing and deployment. So then we have RavenDB. RavenDB is a NoSQL DB. NoSQL, you can Google it. What is a NoSQL DB? It is like a document and what you call collections-based DB, which is much faster than SQL DBs nowadays. Then we have KeePass. KeePass is an open source password manager where you can store username, password, other files, attachments, etc. in an encrypted file, and then you can use it. So that is also a software made in .NET. Then we have Visual Studio, which is totally developed in .NET. Then we have JetBrains Rider. JetBrains Rider is an IDE for Unreal Engine and Windows C++ development. Unreal Engine is also a kind of gaming platform or a game engine with just like Unity 3D. Then we have Parallels. Parallels, as the name suggests, it is used for running Windows on Mac. So it is a software by which you can run Windows on your Mac software. So that is also developed in .NET itself. Then we have LinkPad. LinkPad is an ultimate scratchpad for different kinds of languages like C#, F#, and VB. So it is just for development, not for compilation. So you can write the code, you can see what the results of your code structures are, and then you can transfer it to Visual Studio for complete development for the development ahead. So that is also made in .NET. Then we have Nimble Text. Nimble Text is for performing JavaScript functions Like you can perform different JavaScript functions in this Nimble text platform and then see what the results of your functions are. So it is kind of an IDE. Then we have Balsamic. Balsamic is also a GUI website wireframe builder application, which allows designer to arrange the pre-built widgets. Like if you have seen Jira or Rally, these kind of softwares, these are the Balsamic softwares where we have predefined widgets. You can just drag and drop them, and then you can create your own dashboards. So it is used for that. Then we have Fiddler. Fiddler is an HTTP debugging proxy software application which captures the HTTP and HTTPS data and traffic, network traffic, and make it available for the user to see what all traffics are going on in your network. So similar kind of application is Wireshark, if you have heard about it, Wireshark. So same is Fiddler. Then we have .peek. .peek is a freeware. It is a free software which is used for decompilation of any library. Like you can pick any library, any .NET library, and you can decompile it into an equivalent C# or assembly code. Assembly as in IL code, intermediate language code. And it supports different kind of formats like exe, DLL, WinMD. WinMD is metadata file. So you can use all these and then decompile into the C# or the human readable code. So it's that. Then we have Stack Overflow. As we all know, the Stack Overflow is a website where we can post different kind of technical questions, and we can read the questions answered by the people earlier. So these are the kind of softwares that we can develop with the help of .NET. We can, like, a vast range of things we can do with .NET that we'll see in the further slides. So moving forward with .NET, Microsoft also owns a cloud service called Microsoft Azure, which serves as a cloud software as a service platform for, renting different kind of softwares and infrastructure things. So Microsoft Azure is one. Okay, so moving forward. So we have different kind of software solution providers. Like in today's world, we know, like, we have innumerable number of service providers. Everywhere you can go and find a software developer. I guess in India, every second house has 2 software developers in them. So we have such a wide range of software developers, and so we have such a wide range of software developing organizations. So some of them are purely service-based. Service-based means they take the requirements from the client and develop the software and provide to them. And some are product-based. Product means someone owns a company and designing a product of their own for the use of general public. For example, Microsoft. We have Microsoft Windows operating systems, which is a product of Microsoft. So Microsoft is you can say both mixed, a product company as well as service-based company. So we have different names like cyber infrastructure, Microsoft, Google, Amazon, and similar kind of names. They all are solution service providers. So these are a few of the top solution service providers in today's world globally. So going forward, we have similar hardware solution providers like Amazon, IBM. IBM is one of the oldest and most leading in today's world. Like in US, you can find 80% of the companies using all the hardware of IBM. Like the banking, you can say all the banks, they use IBM hardwares, and all the companies. So most of the companies are using IBM. Then we have Amazon, Apple, Samsung. These are the familiar names that you have heard all over. So these are the companies that develop hardware solutions for softwares. So we can also have tailored hardware solutions today, like whatever configuration you need, whatever processors, RAM, hard disk, and the configuration you need. So these kind of companies, they can provide you tailored configuration as well as pre-built configurations also. So these are the hardware providers. So cloud providers are Google, Microsoft, Amazon, Alibaba. These are the cloud providers in today's world. Now we'll talk about different kind of things we can do in .NET, or what are the different terms which are coined in .NET. So .NET framework, I guess everyone has heard about .NET framework. It is a rich, what represents .NET is .NET framework only. So .NET framework is a rich set of features which encompasses all the functionalities of .NET. Like here you can see entities layer. We have this structure which is n-tier architecture. If you have heard, like we have n-tier architecture in different programming languages also, and similarly we follow the n-tier programming language in .NET. So which are what are the features? The features are single programming model, distributed systems, richer user interface, easy development, and so kind of things. So you can see the n-tier architecture here. We have entities layer. Entities layer contain database entities, service entities, UI models. Like when we have what are entities, like you can relate them to the real world. Like for example, we have a car. We are developing a software for a car. So car is an entity, and its different features are its number of windows, like its number of the tires it has, or the color it has. So these are the different characteristics of the entity car. So anything that exists in the real world can be called as entity in the world of programming. So we have entities layer, then we have presentation layer. Presentation layer, as you all know, the UI layer, where you can see what the programming is all about, like the first page that, or the user interface that opens. So that is UI layer or the presentation layer. Then we have services layer, where we have services going behind your .NET pages or your programming pages. So they are the services. Then we have business components layer, where we have classes and methods. So classes are basically the implementation of the entities. Like if I have a entity car, so I'll have a class named car, and then inside that I'll be having properties like color and number of wheels, number of windows. Then I'll be having methods like run, the car runs. So a method like run and things like that. So that all comes under business components layer, where we define the logic for why we are writing a class. So that comes under business component layer. Then we have data access layer. Data access layer, we write the data for accessing, we write the program or the classes or the methods for accessing the database. And then we have database for interaction. So these are the different kind of layers. Then we have common component layer. Common component layer are the layers which go in parallel to all these layers. Like with the presentation layer also, we can have exceptions, logging, validation, and security concepts, components. Then in services layer also, we can have these kind of things. So they go parallelly with the programming, like the components which we need all through the layers or all through the development. So these are common components layer. So this is the n-tier architecture. .NET framework, so as written in this, it covers all the layers of software development. Above the operating system, as you can see, we have base class libraries, languages, dynamic runtime, managed extensibility, portable class libraries, and Minardi. Okay, let's start with Visual Studio here, high level thing. Visual Studio, we have Visual Studio, then we write code in ASP.NET, or we write Windows code. ADU.NET we have for database interaction. Then we have ADU.NET Entity Framework. This is also a kind of a method for interacting with the database. Then we have WCF, ASP.NET. These are all the technologies for writing code. These Windows Stored App, WPF, Silverlight, all these things are the methods for writing code, the different kind of technologies for codes. Then inside these technologies, we have base class libraries. Then we can choose languages. Then we have dynamic language runtimes. Like language runtimes depend on the languages that we use. Then we have extensibility framework. Then we have portable class libraries. Then we have Minardi. So all these things, they have common language runtime. Okay, WCF. WCF is the framework or the technology of .NET to develop web pages in the 3-tier architecture. Like we have a presentation layer, then we have business layer, we have data access layer. In presentation layers, we have web forms. Then in business layer, we have the actions related to those web forms. And then data access layer, we have interaction with data. So WCF is a kind of technology for developing web applications in .NET. Moving forward, then we have common language runtime. Common language runtime is something like because .NET is a cross-platform thing, we have different kind of technologies in .NET, we have different kind of languages. So all those, to make them work as one, we have common language runtime. Common language runtime supports the compilation, the JIT compiler kind of thing, which compiles the language's code into the intermediate language. And then that Vinarti, I'll explain all this moving forward. WPS, then moving forward, WPS, we have WPF. Okay, so moving forward, I'll explain what are all these things. So we have common language runtime. Common language runtime provides us with the intermediate language code, like compiled code, which you can run on any platform or any machine. It is independent of the platform architecture. So you can interact with any operating system using common language runtime. C#. C# is specifically designed for .NET, as I have told you earlier. So we have VB, C#, C++, different kind of languages. Then we have compilers. Those compilers compile them into assembly, intermediate language code, which we call managed code. Then we have language runtime. Inside common language runtime, we have JIT compilers. Then JIT compiler convert that code into the native code, which is understood by the operating system or the machines. So this is the architecture of, or the execution model of CLR. So here we have written about C#, like C# is an object-oriented, purely object-oriented language, which contains classes, objects. Then we have all the concepts of OOPs, which are supported by C#. So this is the execution model. So here we have a simple hello world program, like the very first program that you'll ever write with .NET C#. So we have the comments, like we represent comments by double slashes, or if we have multi-line comments, we represent multi-line comments by slash and a star, and then ending by a star and a slash. So the comments. Then we have using system. This is the namespace or the usage of the other libraries. System is the parent library. VR is virtual reality. Okay, so we'll take all these in QA sessions. So using system is the parent library of all the .NET classes. We derive everything from system class only. So using system, then we have this namespace hello world. Just like we have packages in Java, so here we have namespace. A namespace is, you can consider a namespace as a package or a container which contains different classes. It is a collection of classes. We can have one or more classes in a single namespace. Then we have class. Class is also a container which contains properties and methods. So inside class, we have main method, and then the main method, we write whatever logic we want to write, or the interaction. So main method is the method which is called directly by the operating system, and it returns the value directly to the operating system only. So here are the descriptions of this hello world program, as you can see. So the output of this is hello world. We can use modifiers, but if we are not using any modifier, then it takes the default modifier of a class. So apart from this, in .NET, specifically in .NET C#, we have one more modifier which is named as internal. So for classes, the default modifier is internal, whereas private is the default modifier for methods. So if we are not specifying any any modifier for methods, it takes it as private. Here it is static. Then we have class as internal. Internal means within the assembly. Like inside this namespace, you can use this class anywhere. So inside the assembly, we can use it anywhere. So default is internal. Yes, it is very similar to Java only. Like we compile it, we create a program, then we compile it. It gives us or provide us with an intermediate language code or intermediate language file, and then we can run it anywhere we want. Similar to Java only. If talking about job roles, we have different kind of job roles. Like front-end technologies, we have back-end developers, then we have full-stack developers. Full-stack developers are those who have knowledge of back-end as well as the front-end both, and can develop the software as a whole by themselves. They are the full-stack developers. So there are different fields that you can pursue, like Windows application developer, you can be a web application developer, mobile, cloud, AI application developer, data scientist, game developer, bot as in robotics. Then you can be testers, like manual tester, automation tester, firmware application developer. Firmware are the softwares infused hardwares. Like we have game chips. Earlier we had game chips in like video games. So those are the firmwares, or the things like we have in washing machines, fridges, automated washing machine, automated fridges. They all contain firmwares. Like we have a chip and we have a software infused in that, which is just read only. You cannot modify it. Those are firmwares. Then we have operating system and system driver developer, because .NET supports languages like C++, which are one of the native languages in the software development. So it is we are able to write operating system and system driver developer. And one more interesting thing, let me tell you about C#. C# is a language, C#'s compiler was written in which language earlier? So C and C++, C#'s original compiler was written in C and C++, but now it is completely rewritten in C# itself. The Rosalind compiler, which is the latest compiler, is rewritten in C# itself. So you can also write operating systems and system driver. You can be a system driver developer as well. Then we have roles like product owner, support engineer kind of roles. There are different, like vast kind of roles you can have in .NET. I'll show you in the coming slides. See, in the entry level, you can be a software development engineer, software developer, project engineer. All these are the same. Web developer, programming, front-end developer. So what responsibilities you have to develop the software, that's it. So these are the things like you participate in routine product builds, design and code reviews, etc., etc. These are the part of development only. Then you can be a test engineer, an analyst, or associate analyst. So in analyst, what you can do is create daily, weekly, monthly reports of, you can just interact with the team, and then you can create the daily reports and things like that. So these are the entry level roles that you can have, like when you just enter into the world of programming. Then second is senior levels. Then you can be senior software engineers. Then you can be team lead, technical lead, project lead. So going forward, the responsibilities keep on growing. Like in team lead, technical lead, you have to lead the team as well, and you have to develop the software parallelly. So both the things you have to do. Project lead, these are all the same. Then going forward, you can be a senior analyst. Senior analyst, it also consult with user, clients, other technology groups. If anyone has some issues and they want to resolve it by the help of different teams. So senior analyst would be the one person who can develop the communication between both the teams and so on. So these kind of things a senior analyst does. Cost estimates, IT planning, risk technology, all these things. Then we have senior test engineer, senior QA engineer, project QA lead. So just like a test engineer, we have senior test engineer who is a bit of experienced person. Then he can also be a QA lead. Like we have a QA team of 2-3 people, then he can lead a QA team. So these are the senior level roles. You can be a senior specialist, like for end-to-end integration. Like we also have integration technologies nowadays. So you can be a senior specialist and can go for integration kind of things. Then you can be a research scientist. Like if you don't want to go into managerial roles, you can go into research roles. So research scientist is one of the senior roles. Then we have top management level roles where you can be project manager, program manager, engineering manager, head of delivery program management. So here what you'll do is like you'll monitor different teams under the project, and then you will ensure that the teams are working fine, there is no problem with the teams, or the communication between the teams is fine, and kind of things, you know, and the stakeholder kind of things also you can have under project manager role. So product owner, you can be a product owner. Product owner means you have all the knowledge of the product in which you are working. And then if anyone in the team or if anyone in the project has some queries about the product, so they can come to you. And the product owner also, what it does is when you have a backlog of tasks, it assigns you the work like according to the roles and responsibilities of an individual in the team. The product owner sees to what role or what task to assign to which person, and how long a sprint will go, or how many tasks will go into a sprint, and these kind of things. All these things a product owner does. Why are you telling about this? Because these are the roles that you can pursue while you go into .NET and programming. So we have country manager, head business development, and director roles in top management. So these are the responsibilities, you can read them. So going forward for case study, we have one case study about the project that I have worked upon. So it was a security information management system. It is a SIM solution which works in a cybersecurity domain. So the product, what